Hey everyone, welcome back to the channel. Today, we're diving into a fascinating cosmic story that feels like something out of a detective novel set in the vastness of space. We're talking about an interstellar visitor, a comet named 3I Atlas, and a recent discovery that has astronomers buzzing. It turns out this celestial traveler isn't journeying through our solar system alone. So, let's set the stage. Back in December 2019, Atlas Survey, which stands for Asteroid Terrestrial Impact Last Alert System, spotted a faint object streaking across the sky. At first, it looked like just another comet. But as astronomers tracked its path, they realized something extraordinary. This wasn't one of our local comets, born in the Oort cloud at the edge of our solar system. Its trajectory was all wrong, or rather, all right for an interstellar origin. This object came from another star system entirely. This made it only the second interstellar object ever detected passing through our neighborhood, after the famous Oumuamua in 2017. Initially, it was designated C 2019 Y4, but once its interstellar nature was confirmed, it earned the prestigious I designation, becoming Comet 3I Atlas. The 3I literally means the third confirmed interstellar object. You might be wondering, wait, you just said it was the second. Well, Borisov was the second, and Oumuamua was the first. The naming convention can be a bit tricky. Now, what makes a comet a comet? It's basically a giant, dirty snowball made of ice, dust, and rock. As it gets closer to the sun, the heat causes the ice to sublime it turn directly from solid to gas. This process releases a cloud of gas and dust, forming a beautiful glowing coma around the nucleus and often a long, sweeping tail. And 3I Atlas was no different. As it journeyed inward, it started to brighten, just as expected. Astronomers all over the world pointed their telescopes at it, eager to study a pristine sample from another star system. What secrets did it hold about its home? What could it tell us about how other solar systems form? The excitement was palpable, but then something strange happened. Instead of continuing to brighten as it approached the sun, 3I Atlas started to fade. And not just fade, but dramatically so. By April 2020, observations from the Hubble Space Telescope confirmed what many suspected. The comet was disintegrating. The intense solar radiation was too much for it. Its nucleus had broken apart into several smaller fragments. It was a bit of a disappointment for those hoping to study a complete interstellar comet up close. It seemed like our chance to get a good look at this alien visitor was literally falling apart before our eyes. The fragments continued to drift apart and fade, and that seemed to be the end of the story. But this is where our cosmic detective story takes a twist. Fast forward a few years. A team of astronomers using the powerful Gemini North Telescope in Hawaii decided to take another look. They were curious. Even though the main comet had disintegrated, could there be anything left? Were any of the fragments still detectable? This is where the real aha moment happened. As they peered into the darkness along the comet's original path, they didn't just find a faint fragment. They found something completely unexpected. Trailing about 2 million miles or 3 million kilometers behind where the main comet's remnants should be was another object. This new object was following the exact same path, the same interstellar trajectory as 3I Atlas. It was like finding a second car following the first one on a long road trip. The team, led by astronomer Teddy Coretta, was stunned. This wasn't a fragment from the 2020 breakup. The physics just didn't work. For a fragment to lag that far behind, it would have had to break off centuries, maybe even thousands of years before 3I Atlas even entered our solar system. Think about that for a second. This implies that 3I Atlas didn't break up because it got close to our sun. It was already in pieces long before it got here. It wasn't a single comet visiting us. It was a small flotilla of icy debris traveling together through the immense void between stars for eons. This discovery changes everything about how we view 3I ATLAS. It wasn't a solitary traveler that met its demise in our solar system. It was a pre-fragmented object, a remnant of some ancient, cataclysmic event that happened back in its home star system. So, what could have caused this? Well, there are a few possibilities. One leading theory is that the original parent body of 3I Atlas got a little too close to its own star, or perhaps a massive planet in its home system. The immense gravitational pull could have acted like a cosmic tidal wave, ripping the comet apart. This process is called tidal disruption. Imagine a giant, icy mountain flying too close to Jupiter. The side of the mountain closer to Jupiter would feel a much stronger gravitational pull than the far side. This difference in force would stretch and tear the mountain apart. The same thing could have happened to the original parent of 3I, Atlas, sending a convoy of fragments hurtling out into interstellar space. This new piece of the puzzle, this escort, is now designated C-2023A3, and studying it gives us a second chance. It's also a comet, showing a faint tail of its own, meaning it's still active. This companion object is essentially a sibling to the original 3I, Atlas fragments. By studying both, astronomers can piece together a more complete picture of the parent body. What was it made of? How big was it? By comparing the composition of C-2023A3 with the data we gathered from the original fragments, we can learn more about the chemistry and structure of the original object. It's like finding the separated twins and studying their shared genetics to understand their parents. This also raises a fascinating question. How common is this? Is Oumuamua the first interstellar visitor also a fragment of a larger object that was torn apart? Oumuamua was very strange cigar-shaped and not showing any typical cometary activity. Could it be that many of these interstellar visitors are not intact objects, but rather the shrapnel from violent events in other star systems? This discovery, made possible by the incredible power of the Gemini Observatory, highlights the dynamic and often violent nature of the cosmos. Our solar system is in a sealed-off bubble. We are constantly being visited by messengers from other stars, and these messengers carry stories of their origins. Sometimes those stories are about quiet, lonely journeys, and other times, as with 3I ATLAS, they're about dramatic breakups that happened long ago and far away. The universe is constantly surprising us. Just when we think we have a handle on something, a new observation throws a wrench in the works and opens up a whole new avenue of inquiry. That's the beauty of astronomy. Every answer just leads to more exciting questions. What else is lurking out there, following the paths of these known interstellar travelers? With new observatories like the Vera C. Rubin Observatory coming online soon, we expect to find many more of these interstellar objects. And now, thanks to this discovery, we'll know to look not just for single objects, but for pairs or even groups traveling together in silent company across the galaxy. Each one will be a precious piece of a puzzle, helping us understand our place in a much, much larger cosmic neighborhood. It's an amazing time to be alive and witnessing these discoveries as they happen. What do you think caused the original comet to break apart? A close brush with a giant planet? A flyby of its home star? Let me know your theories down in the comments below. Thanks so much for joining me on this cosmic journey today. If you enjoyed this deep dive into the mysteries of interstellar space, don't forget to hit that like button. And if you haven't already, please subscribe and turn on notifications so you don't miss our next adventure. Until next time, keep looking up.